Hi guys, welcome to my channel. Here today I'm gonna use one of our recent project to show you guys that when you need a step-down transformer and subpanel in your project, how you're gonna do the calculation, select the material and do the installation.
Subscribe and stay tuned.
As you can see, this is a brand new commercial setup, and here this is the only three-phase 47600 panel is available for this store. And obviously we need 120. So we're gonna install transformer, and based on our requirement, we're gonna install subpanel to provide 120 and 208 power for this store. So this is whole story. So in this video, first we're gonna talk about the calculation for the devices and parts, transformer, subpanel, etc. And then we're gonna talk about the transformer installation and subpanel installation. So this example project is a residential and commercial complex, a big building, commercial on the main floor, and 600 three-phase 100 panel for each unit. You can see from the previous picture, the floor is concrete and the wall is cinder block concrete wall. So start with a subpanel load calculation. First, we need to know our requirement. As we all know, CEC, Canadian Electrical Code, is the minimum requirement for your load calculation. So if you follow the CEC 8-210, other type of occupancy, you first gonna use 8-210A to calculate the basic load in watts per square meter for your whole setup. After that, you're gonna add some special load like electric heat, space heating, air conditioning, motors, like maybe you need a stove, that kind of thing, lightings obviously. And finally, you're gonna add the load calculation for the electrical vehicle charger part. But in here, because we have been doing this kind of projects for many times, we use our best industrial practice to optimize our load calculation. Like either you do the first way or the second way, you use the biggest one, not the lowest one. So the industrial best practice may vary from business to business, obviously. And for us, this restaurant, we use 100% for all the consistent load, like air conditioning, HVAC, ventilation, sump pump, hot water tank, etc. And 50% load of everything over 1.5 kilowatts, which like over anything bigger than one single pole 15 amps, we calculate 50% of all the loads. Then we add 25% of all the remaining circuits. So based on our calculation, I think we need from somewhere between 100 amps to 125 amps. So we go up a little bit. We select the Siemens S3054 L3200 panel. That is like a three-phase 200 amps panel. We're gonna talk about that later. But based on our calculation, it's anywhere between 100 amps to 125 amps. Now comes to the transformer calculation. So first you have to calculate your requirement, and based on that, you choose a transformer, right? So the transformer capacity calculation, and here we use the 600 to 208 transformer, which is a step down delta to Y transformer. First, we need to make sure the calculated load in kilowatts is no bigger than the transformer rated kVA. And based on our maximum amps we're gonna use is slightly over 45 kilowatts. So we're thinking 45 kVA transformer should be good because our range is from 100 amps to 125, max at 125. So we are happy with that. After that, we're gonna choose the transformer over current protection. There's going to be a molded circuit breaker installed on a 600 volt panel. So according to the Canadian Electrical Code CEC 26-250, 252, and 254, depends on the core type, dry type, or white or voltage, you're gonna have a different number for the overcurrent protection. So basically it's a breaker or a disconnect. So we use the 45 kVA divided by 600 volt divided by square root of 3 and times 125% gives you 54 amps. Then you use the Canadian Electrical Code table 13 to get the proper size of breaker. But this is like the maximum amps you can have because 50 amps breaker is readily available there, so we use 50 amps. After that, you need to calculate the conductor because you need to the primary and secondary conductor linking from the 600 panel to your transformer and from your transformer to your 120 and 208 subpanel. Again, we're gonna check the CEC code 26-256, also Appendix B, which requires the primary conductor need to be at least 125% of the rated primary current. Same thing for the secondary conductor size. So you get like 54 amps for your primary, so from the 600 volt to the transformer, and 156 amp from your transformer to your subpanel. And then we need to consider the equipment temperature limitation and check CEC table 2 to get your conductors. Here we use the EMP conduit and pull conductors through the conduit. So for the primary, based on our calculation, we use like XLPE RW90 1000 volt and AW number 6. Actually 600 should be good, but just we go a little bit over the minimum requirement. And for the secondary, it's XLPE RW90 600 volts AWG 2 aughts. We use copper cable here. Actually, you do need to take a look at the CEC code 4-006 because most of the time, the transformer and the panel, the sub panel, they don't have a clear temperature marking on it. If it is not, or you couldn't find it, when the rated amps is over 100 amps, you are using 75-degree column for your table 2. And if the amp is smaller than 100 amps, you have to use the 60-degree temperature column of your table 2. So make sure you notice that for the temperature reading of your conductors, of your panel, of your breaker, and your transformer. Okay. After that, we're gonna select some materials. So the transformer we are using here is the delta to Y 600 volt to 120 and 208 volt 45 kVA, the dry type, aluminum winding, is good for both indoor and outdoor. A dual mounting means like you can mount it on the wall or you can mount it on the floor. That thing alone is cost over $4,000 right now. It goes crazy. And then the overcurrent device. This is the Eaton Cutler Hammer molded case circuit breaker, because you have to follow whatever your 600 volt panel you have there. That breaker alone is like over $1,000. Oh my gosh. And then you're gonna choose your sub panel. Like what I said, the 125 amps should be like sufficient enough. But here we do want more space here, so more circuits here. So we just go up a little bit, choose the 200 amp mil lock with the 30 and 54 spaces, the circuits for this installation. And for the primary, we build 1.25 inch EMT from the transformer to the 600 volt panel, and 2-inch EMT from the transformer to the 120-208 subpanel. Okay. That is our material selection. For the the panel, three-phase sub-panels, anywhere between like $600 to $1,000, depends on if you want a bolt-on type of a panel or breaker or a push-in type. For the EMT and the conductors, the price varies. You don't have to use the copper. And when you do the transformer installation, there's some consideration you need to think about before you even start it. So first will be the location. So this transformer, unfortunately, will be installed in the back side of the store, which is the kitchen. So there's a tap sink over there. So you need to think about the water. Also, you need to think about the ground material, but because we install transformer on the floor, it's concrete floor, it doesn't matter. And the wall structure strength also. Because if it's like smaller transformer, the battery will be installed on the wall. But this transformer, even it is aluminum winding, is still over 400 pounds. And the structural engineer is not quite confident with the strength of the wall, so we have to install it on the ground. So you also need to think about the maintenance. Also, if we put it somewhere too convenient to say a freezer, think what they're gonna do. They probably can open the freezer, pick up a pack of meat, put it right on top of your transformer, which is not what we wanted. Okay, after that, a big thing is about the vibration and noise. This is like a commercial setup, so we don't need to worry too much about that. Otherwise, better install a rubber padding or something underneath the transformer, so you can reduce the noise. And then the last thing, air circulation. The transformer doesn't have any moving parts, but it's still shaking and arms make you heat and noise. Actually, there's a code requirement for certain type of wall material. You need to have enough spacing in between the wall and the transformer, so that the hot air can circulate well. Okay, after that, let's think about the sub-panel installation consideration. Again, location, like water, ground material, wall structure, strength, maintenance. And after that, for all the panel you're gonna install, you need to make sure it's follow the current code. So at here, the highest breaker should not higher than 1.7 meter. So that is the requirement. But to your for your convenience, you can in Canada install the panel upside down or horizontally, as long as it meets all the requirements. So you also need to think about the possible future upgrade. That's why we go up a little bit to 200 amp sub panel. In that way, we have more circuits and more space for future upgrade. So you can also have a splitter box. So each time when you're gonna do something, you don't have to open the panel cover to take everything out. That is one of the consideration also. And last thing will be the three-phase circuit grouping. That's about like a load balancing and how to group the red, black, blue with the neutral properly. Okay, that is all the material and calculation part. Now let's move on to the fun part, installation. So guys, the first thing we're gonna see here is the nameplate of the transformer. You'll see the part number, primary, secondary configuration, voltage, rated current, and the impedance percentage. All the good stuff you need to know before you do your installation. Now let's take a look at the transformer manual. The manual gives you more detailed information, also give you some advice on how to install the transformer. And here is what the transformer inside looks like. In the front isolated bar, you can see the red, black, blue wire here. For the X1, X2, X3, and X0, it's for the lower voltage side, the 120/208 panel side. So basically, this part has a bigger lock and bigger conductors because higher amperage need to go through the conductors. And the H1, H2, and H3 are the high voltage side, the primary side of the transformer. They coming from a 600 volt because it has a higher voltage. Here it has relatively lower amperage. Here we simply connect X1, X2, X3 or H1, H2, H3 using the red, black, blue sequence. Because like for us, the sub panel don't have a rotation sensitive device. So for us, the rotation doesn't matter. Otherwise, you need to think about the phase sequence. And for the lock right in the middle, the biggest one, you can see there's a wire coming from the top marked with the white electrical tape. That is the neutral point of the transformer. So the 3 low voltage winding goes here. And this part also connected with the green grounding wire. So you can see through that lock, this is a piece of a continuous number 6 ground wire. Because like for any reason, if this screw is loose, this transformer itself is still bonded and grounded. You can see on the left, there's the grounding lock there. One for the continuous bonding, and the other one is bonding for the sub panel. And you can see there are 3 coils in the back of the transformer. Those are the core part of the transformer. You also see they are like marked 1, 2, 3, 4, 5 different number there. That is different tabs for this transformer. Because like even this is a 600 to 120/208 transformer, in different plant and scenario, they may not have a perfect 600 volt input. So you use different steps to get your most close to accurate voltage here. You can see we run 2 pieces of EMT conduit to the transformer. On the top is the 1-inch and a quarter conduit for the primary 600 volt side. And on the bottom is a 2-inch EMT conduit for the 120 and the 208 subpanel. As you can see, we installed the subpanel upside down, and because it's a subpanel, we don't jump the neutral to the ground. All the branch circuits goes up through the 2-inch conduit to the splitter box and to the 1-inch encoder conduit all the way to the middle of the store. And finally, thank you for watching and have a great day.